Semiconductor Packaging. John D. Thomas, Alex Ruth. Book 5, Section 2, Chapter 2, Topic 3.
Semiconductor packaging is a multifaceted process that involves assembling semiconductor dies onto carrier substrates, establishing electrical connections, encapsulating the components, and ensuring reliability and functionality. The specific steps of the assembly process can vary significantly depending on the type of package being manufactured, as different package types require unique techniques, materials, and equipment.
In this overview, we will discuss the general steps of semiconductor assembly, highlighting how these steps may differ based on the package type. Die preparation. The assembly process typically begins with die preparation, where semiconductor wafers are fabricated and diced into individual dies. Each die contains a complete set of integrated circuits and serves as the core component of the semiconductor package. The preparation of dies may involve cleaning, inspection, and sorting to ensure uniformity and quality. Die attachment. One of the crucial steps in semiconductor assembly is die attachment, where the semiconductor dies are bonded or attached to carrier substrates. The method of die attachment can vary depending on the package type. For example, in wire-bonded packages, the dies are typically attached using adhesive or soldering techniques. In flip-chip packages, the dies are directly bonded to the substrate using solder bumps or conductive adhesives. Interconnect formation. Once the dies are attached, interconnects are formed to establish electrical connections between the die and the external leads or contacts on the package. The interconnect formation process can vary based on the package type and design requirements. Wire bonding is a common technique used to create electrical connections in traditional packages, where fine wires are bonded from the die pads to the package leads. In flip-chip packages, solder bumps or conductive bumps are used to create direct connections between the die and the substrate. Encapsulation. Following interconnect formation, the semiconductor package is encapsulated or sealed using materials such as epoxy resin or molding compound. Encapsulation provides mechanical support, environmental protection, and structural integrity to the packaged ICs, shielding them from moisture, dust, mechanical stress, and other external factors. The encapsulation process may involve transfer molding, compression molding, or other molding techniques depending on the package type and production requirements. Thermal management. Thermal management is a critical aspect of semiconductor assembly, particularly for packages with high power dissipation requirements. Heat sinks, thermal pads, thermal vias, and other thermal management elements may be integrated into the package design to facilitate heat dissipation and regulate operating temperatures. The specific thermal management techniques employed can vary based on the package type, size, and thermal characteristics. Testing and inspection. Throughout the assembly process, packaged ICs undergo rigorous testing and inspection to verify their functionality, performance, and quality. This includes initial testing to detect defects, functional testing to assess product features, and final inspection to ensure adherence to specifications and standards. Testing and inspection procedures may vary depending on the package type and the complexity of the integrated circuits. Marking and packaging. Once tested and inspected, the packaged ICs are marked with serial numbers, date codes, or other identifying information using laser marking techniques. They are then packaged into trays, tubes, or reels for shipment to customers. The marking and packaging process may vary based on the package type, customer requirements, and industry standards. In summary, semiconductor assembly encompasses a series of general steps that can vary significantly depending on the package type. By understanding the unique requirements and characteristics of each package type, semiconductor manufacturers can effectively execute the assembly process and produce high-quality, reliable integrated circuits for various applications in the electronics industry. Thanks for watching. Please like, share, and subscribe.